Hi there, welcome back. This is a unplanned, unscheduled video. It's an addition to our last video where we talked about relays. This is about solid state relays. You can see you get these print PCB types and you get these in the industrial looking types. I say looking because it's not industrial rated. And people are buying these more and more, and they're becoming more common in both for hobbyists and people alike, where previously it was reserved for industrial use only. But when you buy and order these, there are a few things you need to know, because yes, they are relays, but they don't work as a relay. They work similar to a relay, and that's what I would like to talk about today. But first I'd like to show you a couple of experiments, first with this one and then this one, where we can see how they work and what's going on with them. Alright, here we go. We have a couple of relays. We have a Uno, not a Arduino, and it's blinking on port 13. Just leaving that at the side at the moment. Then we have this solid state low logic relay, and it has a lot of text, but what's important is that we can see it's normally open. That's nice to know. And we have 4 ports for relays, so we would expect them to make a connection there when powered. This one has both header pins and terminals, which is kind of odd, but it's okay. It's a nice thing, I guess. And it's rated for 2 amps, it says. However, yeah, 2 amps is okay. I think it's okay to drive 2 amps to this circuit. They made some nice separation here, and that's for current that's going to creep along the surface, so it has a longer path. So it seems fine on the high end. Yep. Nice little device. And it's not something I would ever use for mains voltage, but I could use it for fun projects, etc. And then we got this one. It's a replica of a industrial solid state relay, and I saw a video where Big Clive actually disassembled it and saw how it worked inside and was built. And just like him, I agree. I'm not 100% sure about these, but they're okay. And I did a few measurements and tried it out for some things, and it worked out okay, but it gets very hot. And when you work on these and they get very hot, you really need something like a cooling block. This one is really nice because it's able to be fitted on a DIN rail, which is cool. But this particular type is kind of annoying, because once you got it on there, you can't get it off unless you slide it off the side. Well, cheap. So mount that on this, and you got yourself cooling. There we go. Today we don't need cooling, so we're just going to leave it as is. Notice it says 3 to 32 volts DC right there. It has a small indicator window, and it says plus and minus. That means the current will run this way. When there's a indicator like that, usually you would expect it to be in parallel with the supply, but in this case it's not. It's actually running straight through the diode. Okay, that's fine. That means it's one directional. Up here we have 24 to 380 volts AC. You can also switch DC with this just fine. Don't worry about it. But now I'm going to show you why these can be a problem to use and what most people seems to have a problem with. So we're going to start with the little one right here. Got my Arduino on the blink sketch. And the first thing I want to do is I want to get some wires, and I want to power this device. So I'm just going to hook up the first couple of wires over here. So let's see, the yellow one is plus and the green one is minus, meaning the green one goes to ground and the yellow goes to 5 volts. There we go. Hooked up to the Arduino. And I want to switch this LED. And a small LED like this is very common to use a 220 ohm resistor. And I'm going to hook that up into my relay just like I always do. Of course, using a relay to switch a resistor is maybe a bit overkill. But the LED really represents a small load. And remember the keyword small load. So here we go. Small circuit. All we need to do now is make sure we connect channel 1, because it says 1 in there. There we go. To the Arduino, and I'm going to connect it to port 13. Oh, let's see, that's a male connector. That's not going to work. There we go, this one. So channel 1, I'm going to hook it up to port 13. Oh, before we do, I'm going to tell you what you would usually expect is this one will blink on, turn this one on, and power will run through the oh my god, you see what I did? I forgot to power the outer circuit. This is completely wrong. Anyway, I expect the power to run up here into the circuit and over to the source again. So let's add a external source. How embarrassing. So it looks like we're using black wire, so why don't we just continue doing that? So we have ground to ground, and let's get some power on this bad boy. Embarrassing, embarrassing. There we go. Let's make sure we have it connected correctly. There we go. Again, I expect this to blink. And before we start, I know it won't. But let's see what will happen. So, there we go. Okay, the first thing I notice is there's not even a slither of light. There we go. I was having a small short circuit up there. Anyway, here we go. You can see the relay is blinking on and off. However, the light stays on. And then people say, why is that? And then the most common thing to think is, oh, maybe there's a MOSFET inside here. And the MOSFET might need ground to actually turn off, so people will take this off and put it to ground, and nothing. That's very strange. Let me Google that then, they say. Well, you don't need to, because what's going on is the thing inside this is a small circuit, and it's called a triac. Triac, yeah. I'm not English, so something like that. Anyway, the point is, it's a small circuit. So here we got a small circuit. This is a small circuit. Except this is put inside a small box. And that box is generating heat. That's why we use cooling. The thing is, it cannot disconnect the power running through physical. It's just adding a current, or sorry, a resistance across this to prevent the power running through. Where this type is actually disconnecting physical connection. This one is only disconnecting. It's not really disconnecting, it's just adding resistance when this is off. However, while this is infinity resistance, this is just a high resistance. So why is this not turning off? Well, of course, when I thought, I think I got a loose connection right here somewhere. Something is up with this. Anyway, the problem with this setup, with the SSD, oh, no. I think the batteries are flat. Yeah, that could be a problem. Do we have spares? Nope. Then I'm going to add a power supply instead. Go. Power supply. Let's see, it's So we're going to go. Now we got power. So away with you. Ground, power, and it's set to 14 volts. That might be a bit high, so let's turn it down to something a bit more friendly. There we go, that's 10. 6 volts, and let's turn that back on. There we go. Okay. It's a circuit that only adds the resistance, so in order to turn that device off, actually off, we need to increase the load. And to increase the load, we either add a dummy load or a snubber. You can Google that. In my case, I'm just going to add this Lego motor. And that's because I know this Lego motor will actually be enough to turn the load off. So it actually works. There we go. And now it's working as expected. You can see it's turning on and off along with pin 13 on the Uno, while it's powered from outside. And that's because we're now drawing enough current or have enough high voltage to be able to turn this device off. And then you ask, when do I know I have enough voltage? Well, you have to Google or look up the sheet, the data sheet for this device, not the entire circuit, but only this device. You can see this is a Omron, which is a well-known company. They usually make PLCs and stuff like that for industrial equipment. So seeing these devices on hobby items like this is quite impressive. There we go, it's working. So let's disconnect that, power off. Well, we can leave this in. We're just going to replace this one with this one, the industrial version. So unscrew and unscrew. There we go. And I'm going to remove the wires. We don't need those. And I'm going to put this away. Then we got this guy. So which order you put them in doesn't really matter in our setup right here. There we go. Oh, come on. Hooked up, and now we just need to hook it up to the Arduino. So this one only has 2 wires to hook up, and I'm going to disconnect the motor just like before, so we only have the light. And the way this works is we power it this way through, and so this one goes to ground, and this one goes to whatever we want to turn on. So if I wanted to turn one of the other pins on or off, I would do that. But now it's pin 13, so let's do that. And then I need to power my external circuit. So I turn my power on. There we go. And there we go. We can see it's just like the other one, continuously on. So again, just like before, this one it's not really leaking current. It's just not physical disconnecting, even just like you should see on the images. But we need to draw more voltage to be able to turn this device off. So I'm going to hook up the Lego motor, and with this one we were able to turn off with the Lego motor, but this one we cannot turn off with the Lego motor. Let's see. It's just going to continuously run, even if I hold it. You can see, as long as it's running, the light is on, even though I'm holding it. this one needs even more voltage than this one to turn off. So we need to increase our load to be able to turn this device off. Meaning, and here it is, this is the problem with using SSD. If you are not 100% sure, you might think the device is off, but it's actually still leaking current through it, meaning you can get shocked and have a very unpleasant day. And people buy these expecting them to just work when hooking them up to a mains voltage, and they will work. But you need to know these will also leak currents, just like this one. They're the same, different sizes, different amount. This one can handle 2 amps, this one can maybe, well, I'm sure it says 25 there, but I wouldn't trust it more than 5 or 10 amps. And another thing, when you buy these knockoffs, look at this, there's no insulation. You can easily touch all the terminals. This makes this a device you cannot use in a mains installation, because you can get electrocuted, or your cat can, or children. Well, I'm only at a few voltage DC, so I'm not so worried, but if I were to hook this up to mains voltage, I would need some sort of cover. And if you buy those just a teeny more expensive, you'll get a plastic cover that would fit over here or something similar. And if I were to switch mains voltage, I would probably buy a 2 or 3 phase connector instead of just disconnecting one phase. But we already discussed that in the previous relay video. It's nice to note that if you're using these and they don't turn off, that's because your voltage, switching voltage, is too low. You need to increase the load. And how much? Well, you need to go into the datasheet for each device and take a look how much you need to increase the load. Okay, here we go. Hope that really helped out some people, because I've seen more and more people talking about, well, they are unable to turn these relays off and they think they are broken. They're not. They're actually just leaking current, and you're not using a high enough load to turn the device off. Important to know when using solid state relays. I have looked up the data sheet. Let's see if we can. There we go. And this one is for the Vaupell. That's this one, the industrial looking type. And we can see it has different specifications. You can see it says trigger current 7.5 milliamps at 12 volts, but I was able to trigger it lower. Yeah. Blocking voltage, minimum blocking voltage. It should be able to block 600 volts. Yeah. Why does it then say 380 on the device? Maybe it's a safety factor they built in. But what's more important is down here we have the schematics or connection diagram, as you can see, and it clearly shows there's a connection back here between the load and the actual disconnects, meaning we have this connection, and this connection is the one that will actually leak current, and the leakage is actually what we experienced when we added the LED onto the device. It wouldn't turn off. And if we continued adding load, eventually we would hit a turn-off point. We also have a schematics for the Omron. And what I just learned about this is that these small black ones from Omron is obsolete. They are going out of production. And I'm sure that is why they are showing up everywhere where hobbyists buy electronics now, is because they stopped production and they are just selling off everything they have of these small devices. And that's most likely because there is a new model and maybe a safer model, or they change some sort of standards where the new model has to abide to that new standard. But yeah, again, it's a better diagram, you can see all the data about the device. We can even see the operating conditions and switching values and some characteristics, but most importantly we can see here how the device is actually connected to the PCB. That's very important if you're going to modify or use it, like I will. Solid state relays, they work as I expect, and now you should expect the same, at least have an idea on how they work. We need to know the switching voltages to be able to turn them off, and remember, they don't actually turn off, they just increase resistance, not infinitely high but very high, meaning eventually current will run through them anyway if you just continue to increase your voltage. I hope it helped out, and thanks for watching. Comment, rate, subscribe, and I think next video is an experiment or small project again. See you there. Bye.